Standard 10. Topic: Geometric sequence and series. Learning area: sequence and series of numbers. John and Arun are going to an exhibition. They are watching a chemical solution which consists of a bacteria. An exhibitioner says that the bacteria double in every hour and he went. Arun is asking John that how many bacteria will be there after 1 hour. John replies that 2. John is asking Arun that how many bacteria will be there after 2 hours. Arun replies that 4. So, it will go 1, 2, 4, 8, 16, 32 and so on. In this lesson, we are going to study about geometric sequence and series. Look at the sequence of numbers. What do you observe from this? Here, each number in the sequence is twice of its previous number except the first number. The ratio between 2 and 1 is 2. That of 4 and 2 is 2. And the ratio between 8 and 4 is also 2. Hence, the ratio between the consecutive numbers is a constant and is called the common ratio. Now, let us see the definition of geometric progression. A geometric progression is a sequence of numbers such that the quotient of any two successive numbers of the sequence is a constant called the common ratio of the sequence. In general, a sequence A1, A2, A3 up to AN and so on is called a geometric sequence. If AN plus 1 is equal to AN times R, N belongs to natural numbers where R is non-zero constant. Here, A1 is the first term of the sequence and R is the common ratio. A geometric sequence is also called a geometric progression, shortly GP. Let us see some examples where the given sequence is geometric sequence or not. Example 1. Is the sequence 3, 6, 12, 24 and so on a geometric sequence? Solution. A sequence is a geometric sequence if AN plus 1 divided by AN is equal to R, which is not equal to 0. So, let us find the quotient between two consecutive numbers. 6 by 3 is equal to 2. 12 by 6 is equal to 2. 24 by 12 is equal to 2. Thus, the common ratio R is equal to 2. Hence, the given sequence is a geometric sequence. The general form of a geometric progression. Consider that A is the first term and R is the common ratio of a geometric sequence. So, A1 is equal to A and AN plus 1 by AN is equal to R for N belongs to natural numbers. Thus, AN plus 1 is equal to R times AN. For N is equal to 1, A2 is equal to R times A1. Since A1 equals A, R times A1 is equal to A times R. We can write R is equal to R to the power 1, which is equal to R to the power of 2 minus 1. Similarly, we get for N is equal to 2 and 3. Following the pattern, we have AN is equal to A times R to the power of N minus 1, which gives nth term of geometric progression. So, a typical geometric sequence is as shown. That is, A, AR, AR squared, AR cubed, and so on up to AR to the power of N minus 1. Now, let us do few problems. Example 1. Find the 11th term of the geometric sequence 5, 10, 20, 40 and so on. Solution. From the given geometric sequence, A equals 5, N equals 11. Common ratio R is equal to 10 by 5, which is equal to 2. We know that the nth term of a geometric progression is A times R to the power of n minus 1. Substituting the values of A, N and R, we get T11 is equal to 5120. Hence, the 11th term of the given geometric sequence is 5120. Example 2. The number of bacteria in a certain culture triples every hour. If there were 20 bacteria present in the culture initially, how many bacteria will be present at the end of 15th hour? Solution. Number of bacteria present initially in the culture is equal to 20. The number of bacteria triples every hour. So, the number of bacteria present at the end of first hour is equal to 3 times 20. Here, the first term A is equal to 20, common ratio R is equal to 3, and N is equal to 15. If Tn denotes the number of bacteria after n hours, Tn is equal to A times R to the power of n minus 1. Substituting the values, we get T15 is equal to 20 times 3 to the power of 14. Hence, the number of bacteria at the end of 15th hour is 9,56,59,380. Geometric series and the sum of first n terms of the GP. A series is a geometric series if the terms of the series form a geometric sequence. Let A, AR, AR squared continuing till AR to the power of n minus 1, AR to the power of n, and so on be a geometric sequence where R is not equal to 0 is the common ratio. Let us find the sum of the first n terms of this sequence. Let sum of the first n terms Sn is equal to A plus AR squared plus up to AR to the power n minus 1. Let it be equation number 1. If R is equal to 1, then Sn is equal to n times A. For R is not equal to 1, then in the equation 1, multiply the left-hand side and the right-hand side of the equation by R. We get R times Sn is equal to R times A plus AR squared plus etc. up to A times R to the power of n minus 1. On simplification, we get AR plus AR squared plus AR cubed plus etc. plus AR to the power of n. Let us name it as equation 2. Subtracting equation 2 from equation 1, we get Sn minus R times Sn is equal to A plus AR squared plus etc. up to A times R to the power of n minus 1 minus AR plus AR squared plus AR cubed etc. up to A times R to the power of n. On simplification, we get Sn times 1 minus R is equal to A minus AR to the power of n, which is equal to A times 1 minus R to the power of n. Hence, sum of the first n terms of a geometric sequence Sn is equal to A times 1 minus R to the power of n whole divided by 1 minus R, since R is not equal to 1. The sum of the first n terms of a geometric sequence Sn is equal to A times 1 minus R to the power of n whole divided by 1 minus R. If R is not equal to 1, we can also use the formula Sn is equal to A times R to the power of n minus 1 whole divided by R minus 1. if r is not equal to 1 and where r is greater than 1. Let us do a problem using this formula. A gardener wanted to reward a boy for his good deeds by giving some mangoes. He gave the boy two choices. He could either have 1,000 mangoes at once, or he could get 1 mango on the first day, 2 on the second day, 4 on the third day, 8 mangoes on the fourth day, and so on for 10 days. Which option should the boy choose to get the maximum number of mangoes? The boy could get 1 mango on the first day, 2 mangoes on the second day, 4 mangoes on the third day, 8 mangoes on the fourth day, and so on. Look at the sequence. The ratio between 2 and 1 is 2, and ratio between 4 and 2 is 2. Common ratio is equal to 2. Hence, it is a geometric sequence. Then, we can find the total number of mangoes for 10 days using the formula Sn is equal to a times r to the power of n minus 1 whole divided by r minus 1, if r is not equal to 1. Here, a is equal to 1, r is equal to 2, and n is equal to 10. Substituting the values, we get S10 is equal to 1 times 2 to the power of 10 minus 1 whole divided by 2 minus 1. That is equal to 2 to the power of 10 minus 1 whole divided by 1, which is equal to 2 to the power of 10 minus 1. That is equal to 1024 minus 1 is equal to 1023. 1000 is lesser than 1023. So, the boy could choose the second choice. That is, he could get 1 mango on the first day, 2 mangoes on second day, 4 mangoes on third day, and so on. Example 1. Find the sum of the first 25 terms of the given geometric series. Solution. Here, a is equal to 16, n is equal to 25, and common ratio r is equal to minus 48 divided by 16 is equal to minus 3. Substituting the values of a, n, and r in the formula, Sn equals a times 1 minus r to the power of n whole divided by 1 minus r. We get 4 times 1 plus 3 to the power of 25. Thus, the sum of the first 25 terms of the geometric series is equal to 4 times 1 plus 3 to the power of 25. Example. The first term of a geometric series is 375 and the fourth term is 192. Find the common ratio and the sum of the first 14 terms. Solution. Given that a is equal to 375 and the fourth term is 192, we know that general term of GP Tn is equal to a times r to the power of n minus 1. Substituting n is equal to 4, we get T4 is equal to 375 times r cubed. Since the fourth term is equal to 192, we get 325 r cubed is equal to 192. Thus, we get r cubed is equal to 192 by 375, which is equal to 4 by 5 the whole cube. Taking cube root on both sides, we get r is equal to 4 by 5. So, the common ratio is equal to 4 by 5. Now, substituting the values of a, R and N respectively as 375, 4 by 5 and 14 in the sum of first n terms of formula, we get the result as shown. The sum of the first 14 terms is equal to 1875 times 1 minus 4 by 5 to the power of 14. Let us learn some special series. The sum of squares of first n natural numbers, summation k, is equal to 1 to n. K squared is equal to n times n plus 1 times 2n plus 1 whole divided by 6. The sum of cubes of the first n natural numbers, summation k, is equal to 1 to n. K cube is equal to n times n plus 1 divided by 2 the whole squared. Example 1. Find the sum of the given series. Solution. We can write the given series as summation of 1 to 25 n squared. The formula for the sum of squares of first n natural numbers is as shown. Here, n is equal to 25. Substituting the values, we get 25 times 26 times 51 divided by 6. That is equal to 5525. Thus, the sum of squares of first 25 natural numbers is equal to 5525. Example 2. Find the sum of the given series. Solution. We can write the given series as summation of 1 to 20 n cubed. The formula for the sum of cubes of first n natural numbers is as shown. Here, n is equal to 20. Substituting the values, we get 20 times 21 divided by 2 the whole squared. Further simplifying, we get 44,100. Thus, the sum of cubes of first 20 natural numbers is equal to 44,100.